morning. Welcome to another episode of How Many Tabs Are Open on Mr. Johnson's Computer. We got more this time. 2, 4, 6, 7. 7 tabs. We are on our second assignment for today, which is the 13th of April. So we're classifying 2D, two-dimensional polygons based on attributes. So attributes are things like congruency. All right, so let's talk about congruency. Remember, congruent means same size, same shape. All right, so some of our attributes are going to be looking for acute angles. Once again, there's that word congruent, which means same size, same shape. So congruent sides, we're looking for sides that are the same size. All right. Obtuse angles, remember, acute angles are smaller than 90 degrees, and obtuse angles are larger than 90 degrees. So an obtuse angle is like whenever you have that relaxed lounge chair. Okay, so first off, let's find the ones with congruent sides. I think that'll be probably the easiest. So what we're doing is we're looking for any of these shapes that have all of the sides the same length. Okay, so we're looking for ones with all the sides the same length. So obviously, square is going to have 4 equal sides, 4 congruent sides. This equilateral triangle also is going to have 3 congruent sides. All right, so we're looking at 1, 2, 3 congruent sides, 1, 2, 3, 4 congruent sides. What else down here looks like it has congruent sides, where all the sides are the same length? So, for now, we might even be able to say this rhombus looks like all 4 sides are the same. All right, and then we're going to take a look at some of these, but I'm going to hold off on those for a second. All right, so I want to review some of these polygons because you have not even learned some of these. All right, so we're going to take a look at some of these polygons. This is a 5-sided polygon over here, this guy right here that I'm wiggling around. 1, 2, 3, 4, 5. 5-sided polygon. A 5-sided polygon is called a pentagon. All right, so this is our pentagon. 1, 2, 3, 4, 5 sides, pentagon. This one, 1, 2, 3, 4, 5, 6 sides. 6 sides is called our hexagon. All right, 6 sides, hexagon. H-E-X, hexagon. All right, and then after that we have a 1, 2, 3, 4, 5, 6, 7-sided polygon. That's a heptagon. H-E-P-T-A-G-O-N. Heptagon. All right, and then there's our 8-sided. 1, 2, 3, 4, 5, 6, 7, 8. I think colons count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and that's our octagon. Octagon, 8 sides, like octopus, 8 legs. Octagon, 8 sides. So pentagon, 5 sides. Hexagon, 6 sides. Heptagon, 7 sides. Octagon, 8 sides. All right. Okay, now that we're looking at that, let's take a look, and we're looking for all acute angles. Do we see any of these with all acute angles? Actually, our triangle has all acute angles too. Okay, so we're gonna have a lot of differences because some of y'all might have been like, I need to put this over here. Some of y'all might be like, I need to put this over here. I'm gonna go ahead and put this over here on all acute angles because really this is one of the only shapes that I see that has all acute angles, right? This one looks like it's got some obtuse angles. This one also looks like it has obtuse angles. This one looks like it has obtuse angles, and this one looks like it has obtuse angles. So I'm guessing, in fact, that they want us to put the obtuse angles over here. However, these also look like some of them have equal sides. So if you put the octagon in congruent sides, I wouldn't think that's wrong because 1, 2, 3, 4, 5, 6, 7, 8, all those sides look the same length. All right, so if you put the octagon, the hexagon, maybe even the pentagon and the heptagon inside congruent sides, it's not wrong. All right, so they really should have made a Venn diagram because then we could have put some of these like in the middle where they show that they have both obtuse angles and congruent sides. So it's a little strange. All right, this one This one has, I think what they're trying to, it's not all acute angles. There's a right angle on this triangle, right? And then these two sides are the same, but I don't think that this side is the same over here. So I'm not really comfortable putting this anywhere up here, unless, I mean, these two sides are shorter than this last side, so I wouldn't say that has congruent sides either. All right. This rectangle, these sides are congruent, and these sides are congruent, but they're not all congruent. And we have four 90-degree angles, so it can't go in acute and it can't go in obtuse. All right. So this rectangle has to hang out over here too. All right, let's take a look at this one. This one is confusing because it has both acute and obtuse angles. All right, so this says all acute angles, and this one just says obtuse angle. So this does indeed have an obtuse angle. If you look at this angle, even though it's upside down, it's larger than 90 degrees. If you stuck a corner of a piece of paper into this corner right here, as you can see, even my little plus mark that is 90 degrees does not fit properly right there. All right, so we can say that this has an obtuse angle. This has two obtuse angles. Here's one of the obtuse angles, and here is one of the obtuse angles over here. All right, same thing with this one. This one has an obtuse angle in this corner and an obtuse angle in this corner. You can use the little arrow on your cursor to see that, but it also has an acute angle right there and acute angle right there. So it's not all acute angles because we have two acute angles and two obtuse angles. So we'll just put this in obtuse angle. So we have a right angle and we have right angles. No, we don't have really congruence. I guess we could say technically this side and this side are congruent and this side and this side are congruent. And then same thing over here, this side and this side are congruent. They're the same size, but this third one is not. So if you leave this rectangle and this right triangle right here on the bottom, I totally understand, because of the fact that they don't really totally fit in any of these. This would be even clearer if it said all congruent sides. Like this, there are four congruent sides. Like this, there are four congruent sides. But on this, we have one set of congruent sides, two sets of congruent sides, but they're not all congruent. Same thing over here. This line over here is longer than these two over here, so they're not all congruent. Okay, so we're gonna have some fun on this one. It looks like we're gonna have some leftovers, because even, non-polygons. It's gonna be easy to find the non-polygons. All right, non-polygons. Look for curves and look for figures that are not closed. All right, we talked about yesterday, polygons are closed figures made of lines. So if you see a curve, that's immediately like a red flag. That's not a polygon because there's a curve. All right, right angles, let's go ahead and look for any 90-degree angles. Those are a little bit easier to find, right? Remember, you can just use your cursor, and if you put your, I guess it doesn't always work. But like for instance, on this one, if I put my cursor in the corner right there, I can see that that's 90 degrees. Maybe if I click off that, yeah. And then if I put my cursor in the corner right there, I can see that it's perfectly 90 degrees, right? All right, so square will also have a 90-degree angle. This rhombus, really, it might look like it's 90 degrees, but if we flip it sideways, we realize that it's not 90 degrees. It's slightly acute on these angles and slightly obtuse on these angles. So this is actually just going to be a polygon, all right? It's not going to be a right-angled polygon, even though it almost looks like a square. If we flip it sideways, we see that it's not. All right, there is our six-sided polygon. What was that called again? If you said hexagon, awesome. Your six-sided polygon is a hexagon. I just want to write these out because I don't think they showed you in writing anywhere what these things are. So there we go. That's a hexagon. I guess I could make the label fit a little bit better than that. There we go. You don't have to do this, but this is helpful because you do need to know these words. All right, here's our five-sided polygon, and that one was called a pentagon. Right? So there's a very important government building in Washington, D.C., called the Pentagon, and it's shaped like that. All right, let's count these sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8. I can't count today. All right, we're going to try this again. One side, two sides, three sides, four sides, five sides, six sides, seven sides, eight sides, nine sides. Okay, we got 9 sides. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, is that 10 sides? Let me get the blue box off. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We got that. Okay, that's 10 sides. Okay, so when you're doing this on paper, it's really easy to like mark your sides to count them, but when you're doing this on a computer, it can be a little confusing. So double check when you're counting your sides to make sure that you haven't double counted a side or left a side off. This is a 10-sided polygon called a decagon. Think about 10 years as a decade. 10 sides is called a decagon. All right. All right, let's count the next one. 1, 2, 3, 4, 5, 6, 7. Remember, a 7-sided polygon is called a heptagon. All right, that one's a little bit weird. Heptagon. All right. Do do do. So we have a 6-sided polygon, a hexagon. We have a 5-sided polygon, a pentagon. We have a 10-sided polygon, a decagon. We have a 7-sided polygon called a heptagon. All right, and this right here, that's a trapezoid. We can tell because it's a quadrilateral with 4 sides, and if we follow 2 of these lines straight out, it'll kind of make a triangle. So we'll have intersecting lines. All right, we also have a triangle, 3 sides, 1, 2, 3. That is a polygon as well. And then finally, we have a parallelogram. It's kind of like a rectangle, except for these 2 sides are parallel, these 2 sides are parallel, but this doesn't have 90-degree angles. A rectangle would have 90-degree angles as well. This is a parallelogram. All right, so there's our right angles, there's our polygons, there's our non-polygons because they have curves. Okay, let's see what's next. Okay, so we have to label these correctly. So we have has at least one set of parallel lines, has at least one obtuse angle, and has at least one acute angle. All right. So let's start off with, let's say, has at least one set of parallel lines. All right. Because there's a lot of quadrilaterals in here, I know that quadrilaterals typically have a lot of parallel lines. So I'm looking at all these, and yeah, the rectangle has at least one set of parallel lines, has 2. So does this parallelogram. This square has 2 sets of parallel lines, and this trapezoid has 1 set of parallel lines and 1 set of intersecting lines. So it has at least 1 set of parallel lines over here. All right, now we need to find at least one obtuse angle, right? At least one obtuse angle. And remember, all of these big polygons over here, like the 7-sided heptagon, the 10-sided decagon, the 5-sided pentagon, or the 6-sided hexagon, they all have at least one obtuse angle because all of these angles here are greater than 90 degrees. All right, a lot, like basically, once we get more than 4 sides on a polygon, we're going to have a lot of obtuse angles. All right, so triangles have right angles, acute angles, obtuse angles. Parallelograms have obtuse angles, right angles, and acute angles. But a lot of these polygons that come after 4 sides, so 5 sides or beyond, have obtuse angles in order to close the shape. All right, and then at least one acute angle. I see acute angle right there. I see acute angle right there. And I see acute angle right there. All the acute angles have less than 90 degrees. So we can see that there's at least one acute angle in each one of these. There is a right angle over here, but the other 2 of these are acute. So it says has at least one acute. And then finally, we have, once again, some polygons over here, some quadrilaterals over here, and then we have triangles and non-polygons over here. So let's see if we can label this correctly. So we're looking for quadrilaterals. So quadrilaterals, that means polygons with 4 sides. So these obviously have more than 4 sides. We've talked about, once again, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, and then 10 sides decagon. All right. So quadrilaterals have 4 sides. All right. All of these, because they're pentagon or beyond, have more than 4 sides, 5 sides, 6 sides, 7 sides, 10 sides, and then has at least 3 sides. Even though these two aren't polygons, they do indeed have one. Actually, this doesn't have 3 sides. It has 1 side. Oh, 3 or less sides. Yeah, that makes sense. Has at least 3 or less sides. 1, 2, 3 sides, 1 side, 1, 2, 3 sides, and then 1, 2 sides. Remember, the curves don't really count as a side. The curves are not even lines for 5th grade. All right. So it has at least 3 or less sides. That would be a triangle or some of these non-polygons. Okie doke. So we've made our way through. This was probably the most confusing page, especially the way that I set it up. So hopefully you listened to that part, because we could have put several of these in many places. So other than that, I hope that you're having success with the geometry stuff. Please reach out to your teachers if you have any questions. Feel free to like and subscribe if you want to or something. And yeah, I hope that you have a wonderful day. And yeah, reach out to us if you have questions, and we'll see you later. Have a good day. Bye.